Hello, everyone. Thank you so much for joining us today for our webinar, Determination of Protein and Carbohydrates in Novel Upcycled Protein Materials. I'm very excited to have Mollie Van Alst here with me today to host the webinar. I am Amy Knock, and I will be moderating today's session. Before we begin, I just wanted to let you know a little bit more about how the webinar will run. This webinar is being recorded and the slides and recording will be available to you within 3 business days. A short Q&A session will follow the presentation to answer any viewers submitted questions. During the webinar, you can submit questions you have using the webinar sidebar menu. Select the Questions tab, type in your question, then hit the Enter key on your keyboard. Remember, you can submit questions anytime throughout the presentation. That concludes my very brief introduction today. Mollie, I will now pass it over to you. You may begin your presentation.
Awesome. Thank you, Amy, for the introduction. Let me go ahead and turn on my webcam here. All right, hopefully everybody can see me. Good morning, everyone. And again, thank you, Amy, for the introduction. As she mentioned, my name is Mollie Van Alst, and I am one of 2 analytical service managers at our Nutrition Analysis Center in Des Moines, Iowa. So I know I usually start out these webinars by saying that I know that probably doesn't really explain what I do in my role, but essentially my role is to provide a higher level technical support to our clients when they're starting new projects with new types of products, or whether or not they're troubleshooting routine testing. And truly my main function and focus is to hone in on nutrition labeling regulations and keeping those in perspective when it comes to services that we offer here in the lab, as well as what gaps are within the current industry and the technical challenges that arise with respect to the labeling regulations. So today we're going to sort of talk about an alternative method of determining protein and carbohydrates in novel and upcycled protein materials, which you know because you've signed up for this webinar. So without further ado, let me just switch off my camera real quick. Okay, so hopefully everyone can see my next slide here. Before we get started, I do want to touch on the overview of subtopics today because I do think it's really important that we share with our customers and are transparent about how we arrived at the new service and what is the overall intent behind it. So in order to really do that, you have to understand the basic components that are involved in the problem and the challenges that we're facing, and how the FDA's CFR dictates that we have to handle nutrition labeling and the limitations that come along with that when you consider these new matrices in the market. So really the first half of this presentation is going to focus on providing you with a very basic understanding of protein and carbohydrate composition, as well as the routine analysis or calculation as outlined by nutrition labeling regulations. And then we can really jump into the second half of the presentation, which really describes how these 2 macronutrients contribute to a mass balance discrepancy in novel and upcycled protein materials. And of course, I'm going to explain what this mass balance discrepancy is and what it means to the consumer or someone looking at the nutrition facts or your analytical report, as well as the new service I'm going to describe that Eurofins in Des Moines is offering to support our clients when they face this challenge with their product. So I'll go ahead without further ado and kind of get started with protein. I mentioned we're just going to briefly talk about composition and routine analysis and how that historically came about and how we determine protein today. So almost everyone knows, whether you're in the food industry or not, protein is an essential macronutrient in the human diet. So we know it's important for energy, and it's also a mandatory NLEA nutrient when significant in the product. So basically, the FDA and USDA say that you need to declare your protein per serving on a nutrition facts panel. So if we really truly break down protein and you go back to your high school chemistry class, if you remember them telling you that amino acids are the building blocks of protein, and that is true. So they're bonded in the dehydrated form. And I have an infographic, or I guess a little graphic example of what that might look like. So you can see 2 amino acids there losing their H2O water molecule and forming a peptide bond between carbon and nitrogen. And they are forming what is protein. So 2 amino acids becoming bonded into protein. So essentially that is your building block. But if you break that down even further, and this is really important when it comes to understanding how protein is tested. So amino acids contain certain molecules like oxygen, carbon, hydrogen, and nitrogen, which is the one we're going to focus on. When you think about your other macronutrients or the nutrients in a nutrition facts panel, all of them contain things like oxygen, carbon, and hydrogen. Some of them may contain nitrogen, but when you look at amino acids, what's consistent among all of them is that they all contain nitrogen because it's crucial for the peptide bond and forming those proteins. So that is important to keep in mind when we get into the next slide and talk about how protein is actually measured and how that came about historically, and it's actually still used today. So I kind of alluded to, after we discussed the protein composition, I alluded to the fact that we measure this by an indirect determination. And to kind of explain what this means, so I mentioned that proteins are composed of amino acids, and all amino acids have nitrogen. So really and truly, you can measure the nitrogen by heating the sample and converting that nitrogen to protein by a specific multiplication factor. So this is a indirect determination because we're not actually measuring the protein, we're measuring nitrogen and calculating to protein. So these are quick and dirty, is what I call rudimentary methods that were established a long time ago, have not changed that much, especially with respect to the factor that is used to calculate protein. But really here, what I want to drive home is that amino acids, the protein analysis that we use today is really derived off of the premise that all amino acids contain nitrogen, and that which we know not to be true is kind of exclusive to amino acids. And I'll touch on that in a little bit here. So I talked about on the last slide how protein is actually a calculation from nitrogen that is measured. So I referenced that there's a factor that is used to calculate protein. So generally speaking, most of the time, 6.25 is going to be the factor that is used to convert to protein. So I have a snip on the right-hand side of the slide here from the FDA's 21 CFR for nutrition labeling, which explicitly states that you need to use 6.25 as determined by official AOAC methods, unless when otherwise specified. So there, of course, with everything, there are a few exceptions. One that's notable and probably pretty common to most is dairy, and then there are some for wheats and grains and things like that. But generally speaking, especially in finished goods, 6.25 is the factor that needs to be used and is dictated by the FDA in the CFR. So you're probably kind of wondering, okay, well, where did 6.25 come from? And I will explain that, as well as the limitations that come with that. So when you look at the basis of early determinations, when they were trying to determine protein and average nitrogen content, things like that, they were looking at animal sources of protein and animal feed. And so when they were looking at that, what they found was that the nitrogen content of proteins was about 16%. Which, when you quote unquote, like what I like to say, math that out, when you take 1 divided by 0.16, you get your factor of 6.25. So that was kind of then universally adopted into the nutrition labeling regulations as the appropriate factor to use. What we know today is that that's not necessarily true for all proteins, especially with the new upcycled and high protein ingredients that we're seeing today. So going back to, one of our previous slides, I mentioned amino acids contain nitrogen. Well, what we know today is that the individuals, so there's about 20, I think 20 amino acids, they range from 8 to 32% nitrogen. So the use of a universal factor of 6.25 is illogical when you really consider the fact that different amino acids contain different levels of nitrogen. So the nitrogen content of specific amino acids actually varies according to the molecular weight and the number of nitrogen atoms that it has. So again, in bullet 3 on the left-hand side, you can see that I've listed the individuals range from 8 to 32%. So then based on the different amino acid compositions and the ones that bond to form the proteins, the nitrogen content in literature has actually been shown to be probably somewhere between 13 to 19%. So again, if you quote unquote math that out, similar to the 6.25, when you divide those percentages by 1, you actually get a factor range of 5.26 to 7.69. So that doesn't seem like a huge difference from 6.25, but you have to think about it in the context of when you're multiplying that number by nitrogen, it can extrapolate, usually overestimate the protein that you're seeing, and we'll kind of touch on that further, but that can actually extrapolate to a much larger, more significant number. So that's really the first problem with 6.25 is you have individual amino acids are composed of different amounts of nitrogen, and when bonded, they're obviously going to have different levels of nitrogen as well. The second thing that really makes 6.25 illogical is that we also know that not all nitrogen is found in food proteins. So kind of, again, going back to a previous slide when I talked about amino acids being composed of oxygen, carbon, hydrogen, other macronutrients and nutrients are composed of those as well. And you're basically, with this approach, assuming that nitrogen is exclusive to amino acids found in protein, and it's not. There is naturally occurring nitrogen that is not bound in proteins, and great examples of that are, free amino acids, nucleotides, creatine, choline. These are all things that are considered non-protein nitrogen. So really a lot of information about this slide, but the two problems that I want you to remember here with 6.25 is that, number one, different proteins are made up of different amino acids, and different amino acids have different levels of nitrogen. And also, not all nitrogen is necessarily related to protein. So with that, I know that's a lot of information, and it will tie in together towards the end of the presentation, but I want to pivot and talk about carbohydrates, again, to really give you a basic understanding of, these nutrients, where they're coming from, and where the problem lies when we start applying them to nutrition labeling. So to talk about carbs a little bit, again, very similar to protein in that it is an essential macronutrient. And what can be confusing to some people is that carbohydrates actually, it's a representation of more than one thing. So it can be a sugar, a fiber, a starch. So all of those things are actually subclasses of carbohydrates. So again, when you're looking at, the 21 CFR, the Code of Federal Regulations for Nutrition Labeling, of course, the FDA tells us how we must come to a carbohydrates value. And it's actually what a lot of people don't realize, we don't actually analytically test for carbohydrates themselves. Same with what's dictated in the CFR. It's actually calculated by subtraction of other things that we analyze. So the common way to describe it is 100 minus proximate is your carbohydrates value. Proximate is things like your fat, moisture, ash, and protein. So what's important to understand about this is that anything that's not quantified in your analysis for fat, moisture, ash, or protein will inevitably be counted as a carbohydrate when you use the FDA's definition. So I have, it's kind of silly, but I outline it there below. When you take 100 minus fat, minus protein, minus moisture, minus ash, you get carbohydrates, which again, as I mentioned, is generally a reflection of your fiber and sugars in the product, sometimes starches and other things. But what's important and key to remember here, and what will make more sense when I describe our issues, is that fiber and sugars, because they are types of carbohydrates, individually or some together, they should never theoretically exceed carbohydrates because they are subclasses of them. So again, that will make sense in a minute here when I show you this graphic that I put together that really just ties in all of the information that I've already presented, and then, kind of brings you to what the core issue is and what we're trying to address with our new service. So you can see here, just starting with protein, we know protein is made up of amino acids, and amino acids are all, they all contain nitrogen. So a quick way to determine that protein is measuring nitrogen and applying a 6.25 factor. We also know that carbohydrates are mainly a reflection of your fiber and sugars, can be some other things, but in general, those are what compose your carbohydrates. And it's also what is dictated on a nutrition facts panel. So the FDA regards those as mandatory nutrients that need to be listed under carbohydrates, and they are calculated, not tested, but calculated by taking 100 minus your fat, moisture, ash, and protein. So when you think about that and tie it all together, the higher your protein is, because carbs is a calculation using that value, the higher your protein is, the lower your carbohydrates value is going to be. Now remember, fiber and sugars are classes of carbohydrates that we test individually. So when you are having a high protein product that is lowering the carbohydrates due to the inapplicable 6.25 factor, you are increasing your opportunity for the components, fiber and sugar, to exceed your calculated carbohydrates. Now, I'll run through a number example here in a minute, but I want you to take a look at the nutrition facts panel over to the right on the slide, which really shows this issue, plain and simple. So this is a high protein powder product that is a novel material. It is a whey alternative, so it comes from a plant-based source. That is the main contribution of protein. So you can see in this example where we quantified fiber and sugars individually, they're totaling up to 7, where your calculated carbs, because that comes from your proximate values, remember, those are 5 grams. So you've now got 7 and 5. So it really makes sense when you consider the fact that the FDA has formatted the nutrition facts panel so that fiber and sugars are indented under carbohydrates. So that's really telling the consumer, hey, these are subclasses of carbohydrates. So when a consumer looks at this and says, okay, well, why do they exceed carbs? That can be pretty confusing, and it's also misleading. And you can see there with that elevated protein level of 68 grams per serving, which is extremely high, that is, you can kind of identify that this is probably one of those products that has an issue with this. So I mentioned that I would go through a number example and kind of talk about what this is. So fiber and sugar exceeding carbohydrates is a no-no. It's what it can be referred to as a mass balance discrepancy, because it's a direct contradiction to the consumer expectation that fiber and sugars are, classifications of carbohydrates and shouldn't exceed the carbohydrates. So as I've alluded and deduced to, this is usually caused by the inflated protein of an inapplicable 6.25 factor. So again, kind of helpful to visualize another example below. If you see your protein there on the left-hand side is 75%, your fat is 10%, your moisture is 5%, and your ash is 3%. when we use our FDA calculation, our carbohydrates come out to 7%. So now let's take a look at if we change that protein number by 10% and it's 65 and all of the other proximates stay the same. Automatically, your carbs is going to increase because whatever's not quantified in those 4 macros are going to be counted as carbohydrates. So in conclusion, the higher your protein, the lower your carbs is going to be, and that's going to increase your opportunity for fiber and or sugars to exceed carbohydrates. So what matrices are experiencing this mass balance discrepancy? So in general, it's products and ingredients where ta-da, the 6.25 factor isn't appropriate. What types of products are those? It is the topic of this webinar. So those novel and upcycled ingredients. And I want to say that they are often, probably 99% of the time, the plant-based ingredients. So when you think about how I described that 6.25 came about originally, remember that factor was evaluated using animal sources of protein, what was traditionally, in the diet at that time. So it was very representative of things like red meat, chicken, those animal sources of protein. So yeah, you typically won't see this issue in high protein materials that have been tested historically and fit this factor very well. But when you start looking at the plant-based materials in the market, the novel or upcycled ingredients, this is where the issue occurs because those weren't historically tested. There's, the factor was not considering these new matrices that we have in the market because our diets and trends in the market have evolved. So usually when these materials, they're in the raw material form is when we see the exaggerated mass balance discrepancy. So usually this is when your fiber and sugars maybe greatly exceed your carbohydrates is when we're testing the raw material. So the nutrition facts panel that I put as an example on the previous slide of the whey alternative protein powder is a great example of where we see this occur. Fungi-based proteins, otherwise known as mycoproteins, we definitely see this occur in these types of samples. Also, traditional sources, but when they're isolated from the original source in high concentrations and blended together, so pea, barley, rice, those things we can see. As well as I touched on earlier, there are just some things that have a lot of non-protein nitrogen. So seaweed and algae biomass, when you're looking at like the components of sushi and the seaweed wraps and things, those can actually exhibit this issue as well. So I mentioned it's very exaggerated or can be exaggerated in the raw material form, but we can also see this in the finished goods. But it's usually much less severe. The difference between your sugar and fiber maybe isn't exceeding carbohydrates by too much, and sometimes we can actually, within acceptable FDA rounding rules, we can manipulate that carbs value on a nutrition facts panel to not cause consumer confusion but still be accurate for the product. So finished goods, not necessarily as much of an issue, but we still do certainly see it, and it's still, sometimes it is a little bit more severe depending on the ingredients in the product. So the reason that you're usually going to see this occur more exaggerated in the raw material form is, I have a picture of a pea over there and a plant-based burger. When you take example like a highly processed pea protein, testing that may exhibit the issues. However, when you're putting that into the finished good, which is maybe a plant-based burger, you're adding other ingredients into that formula that are probably also contributing fat, moisture, ash, and protein. So there's kind of a balance there that ends up kind of smoothing out your carbohydrates calculation. And so maybe that is due to what doesn't make it as severe in the finished good. but we definitely see this for sure in the raw material products. So this kind of leads into the new service that I'm going to touch on, as well as so kind of an alternative way of calculating protein that actually, has been around for a long time. But protein calculated from the amino acid residues or the dehydrate forms is really a direct determination of protein. So I touched on the fact that the nitrogen method really is an indirect, because you're measuring a component of protein. So with this, you're doing a direct determination. So in theory, it's much more accurate. But because those proteins are made up of chains of amino acids by peptide bonds, we can hydrolyze them and then quantify them on the LC into their respective component amino acids. So then when we subtract the water weight, because they're bonded in the dehydrated form, when we subtract the water weight, we can sum those together and actually give you a scientifically truer protein value. So the advantage to this approach is really that it doesn't require any knowledge of, the non-protein nitrogen content of the food or your relative proportions of specific amino acids, because you're basically removing those problems that you have with the nitrogen method. So it's catered to the specific product we are testing based on that amino acid composition. So with our new service at Eurofins Nutrition Analysis Center in Des Moines, what's really important here, again, I said the amino acid profile, that's something that, has been done for a long time. That is not new, but what we are offering in tandem with that is relatively new, because it kind of goes against, for lack of a better phrase, what the FDA says you have to do. So to kind of get into that a little more, the service will include an amino acid profile. And then, as I described earlier a little bit, what we do is we take those dehydrate forms from that profile and we calculate the protein for you. So when you order this alongside your routine proximate values, so your fat, moisture, ash, and then the traditional protein by nitrogen combustion, when you order those in tandem, we will also calculate an adjusted carbohydrates value. So this is basically using the same formula, the 100 minus proximate, but we're going to swap out that protein from nitrogen combustion with the protein from amino acid dehydrates, thus recalculating your carbs and hopefully eliminating or reducing the mass balance discrepancy that you see in a nutrition facts panel or on your analytical report. So this is that, again, that fiber, sugar greater than carbs. If we're substituting in a more appropriate protein value, your carbs is hopefully going to be bumped up, and your fiber and sugars will be within that acceptable range. So with this, it is super important that I touch on the next point, which our proposed solution is not, and I recognize is not an immediate solution, but rather pushing for change in the long term. So the FDA, despite, we have reached out several times seeking clarification, they have not formally acknowledged protein by AA as an appropriate alternative to the nitrogen by 6.25, even though you can do PDCAS for certain labels. This means that you have to use nitrogen by 6.25 in your nutrition facts panel along with the traditional carbs calculation. So you have to use the data that contradicts itself, essentially. However, this new service gives you tangible scientific data to show a truer protein value for your specific product that can be used in a formal petition to the FDA requesting an alternative protein factor. So as I mentioned, we've contacted the FDA several times to discuss this issue without, really a concrete response or direction other than use what is dictated in the CFR. And so in the past, we haven't really been able to advise our customers on how to approach this, what to do, whether or not their label, is something that they can proceed with, putting on the package, because the regulations that we're given are just contradictory. So I mentioned that filing a petition for protein factor adjustment, it's not a quick or immediate solution. It is time consuming and lengthy. However, when you consider the current state of the market and where we are trending, it becomes really important for manufacturers to push the FDA to revisit these protein regulations. Think about the market today as opposed to 10 to 20 years ago. More and more plant-based protein products are in the market today. And that's to support, various different diets and lifestyles. So, vegan, vegetarian, but also many of the companies are focused on a sustainability approach. So when you think about how we're going to feed growing populations in the years to come, plant-based materials become extremely relevant. And they support the notion that this market is not going away and will just continue to evolve. So without reconsidering the standard approach, we will continue inevitably to put out nutrition facts panels that may not accurately reflect the product protein or carbohydrates ipso facto, and is also extremely confusing to the end user. Also, it makes the manufacturer or the testing lab look like they don't know what they're doing. So not to mention, you also have another aspect when many of these ingredients we test in the raw material form for NLEA testing, so the full nutritional profile. So when those are provided or sold to finished good manufacturers and they're formulating based on an inflated protein value, you're going to cause more problems down the line. And so that's going to be problematic in the long run, especially when you consider the fact that these matrices probably are not going away. So essentially, my point is that to really make an impact and change standard practice, manufacturers must drive this change along with the testing labs, and Eurofins has that capability to help our clients do that. So the more petitions that are filed for these alternative proteins will hopefully sway the FDA to revisit the protein determination method and appropriate conversion factors more quickly. And with more petitions, that will demonstrate that there's a significant problem with current practice with respect to the foods that we eat today. So I know that was quite a bit of information in a short amount of time. I could talk about this topic all day, every day, but I really wanted to drive home the key points as far as, what are we looking at? What are the problem nutrients that we see? Why are they problematic? What matrices they're problematic in, and how Eurofins can help you with this approach. And certainly if there are questions, I'm happy to take them at this point, and I'm also happy to connect with anyone via email or phone to discuss further. But that is my presentation for you today.
Thank you so much for that, Molly. Now we'll move into a short question and answer session. Again, feel free to continue to submit questions during this time. And of course, if we don't address them live during the presentation, we will follow up with you directly after the webinar. So there have been just a few questions that have come in here to the chat. So the first question for you, Molly: how is this service different from PDCAS, and when should I request PDCAS?
Yeah, so that's a great question. I kind of briefly touched on PDCAS at one point in the presentation, just kind of noted it, but this service that we're offering is almost kind of like half the steps of PDCAS. So PDCAS refers to your protein digestibility corrected amino acid score. That's actually the point of PDCAS, is to determine the digestibility of the protein, because not all protein is equally digested. So we are running the amino acid profile to determine a true protein calculation. However, we're not going a step further and determining the digestibility of the protein so that %DV can be displayed. So if you look at a nutrition facts panel, any nutrition facts panel really, you'll probably notice that %DV for protein is not displayed. And really that's because at the time regulations were created, the FDA stance was that protein wasn't really a concern in the diet. So, and also, as I alluded to, the digestibility is different between proteins. So they just negated having that unless there are, certain contingencies around displaying that. So when you're using PDCAS, the primary purpose is if you're trying to make a claim about high protein and you need to then consequently display the percent DV on your nutrition facts panel, you'll need your PDCAS. You'll need to determine the true digestibility of that protein. And also for infant formula and diets, PDCAS and PER is somewhat compulsory for certain things like that. So really and truly, you kind of look at it as half a PDCAS because we're determining a truer value of protein, but we're not doing the digestibility portion of it.
Great. Thank you so much for that explanation. Next question that has come in, can dietary fiber or sugar be the root cause of mass balance discrepancies, or is it always protein?
Yeah, so that is another really great question. So you'll notice I mentioned that fiber and sugar are tested separately in an NLEA profile and carbs as a calculation. So most often what we see when we see a fiber sugar greater than carbs issue is directly related to an inapplicable protein factor. However, that is not always the case. We have found that in novel and upcycled materials or raw materials that are high in fiber, sometimes the issue is not necessarily the protein factor. So if they're high in protein or fiber, fiber is actually a subtraction method. And what I mean by that is when you're determining fiber, you're stripping things like fat, sugar, and moisture where applicable, and then enzymatically digesting protein to remove all of that from the sample. And what's left is actually your fiber. So when you have high protein samples, the enzymes that are added may not necessarily completely digest that protein, and so you're not completely removing it from the sample, and that could be counted as fiber. So sometimes in these same high protein materials, you can actually see fiber being part of the root cause because, again, it all stems back to protein. The high levels of protein may not necessarily be completely removed with the method, so you can see that occur. But in general, most of the time, what we're seeing is the inapplicability of the protein factor.
Got it. Thank you. And I think this was a clarifying question. So this one came in to confirm total grams of protein would be the sum total grams of all amino acids. And then does that also include tryptophan?
Yeah, so if I understand the question correctly, basically your protein calculated from amino acids is going to be the sum of those amino acids, but in the dehydrate form. So let's say you request an amino acid profile from us run on your sample. You can't just take those values that we reported and add them up and determine your protein. You actually have to subtract the water molecule because I kind of briefly mentioned it. They're bonded in the dehydrated form. So we actually go back and subtract that water molecule and calculate the true protein based on that. And I think, was there a second part to the question? I'm sorry, Amy.
Then the follow-up was, and does that also include tryptophan?
Yes, thank you. So it does. We do include tryptophan in that calculation as well.
Wonderful. Okay, thank you. And then another question that has come in is how does the actual protein content in plant-based proteins compare to the calculated one using 6.25?
Yeah, so that's a great question as well. What we have generally been seeing is about a 10 percentage point difference. So to put that like a numerical like example, we usually see sometimes like 68% protein coming out of these plant-based materials, but when you do the amino acids, it's usually like 55 to 58. So it's usually about a 10 percentage points difference between the methods.
Wonderful. Okay, thank you for that. And I think we have time for one more question here. I see a few other questions that I think we touched on, but maybe we'll wrap it up with this one here. The next question that has come in, do you see a trend moving towards characterizing proteins at the more intact level, given the growing popularity of top, middle, down approaches to simplify sample preparation time or cost?
Um, I'd honestly have to look into that a little bit further. I would say possibly. I think right now it's hard to say because the FDA hasn't really, you know, I guess given us like concrete responses to what they're going to be doing moving forward, or they haven't seeked any, information about it. So I would say that's definitely something I could maybe look into and follow up on, but probably don't have, an immediate answer, but definitely a great question.
Wonderful. Okay, thank you so much. And for that question, we have all your contact details so we can certainly follow up. It looks like we are getting caught up with the questions here. So I think that will wrap up our Q&A session. I just want to remind everyone that a recording of this webinar, along with a copy of the slides, will be available to you within 3 business days. And again, I want to thank you so much, Molly, for your presentation today. And thanks everyone for attending.
Thank you, Amy. Thank you, everyone, for joining.
Thank you.